the 6 over 8, if I reduce it, it equals the 3 over 4. All right. So let's see, does it work on C as well? C goes with J. So if I write the ratios for both C and J, well, C, my side lengths are 3 and 9. So I put the small one on top, 3 over 9. And then J is 1 and 3. So I put 1 over 3. And then notice yet again, yep, they are equal to each other. So what we're kind of noticing here is we are now finding another way that we can determine if they're similar or not. If we just look at the ratio of the sides next to each other, the adjacent sides, if that ratio is equal to the ratio in the other shape, then we know they're similar to each other. Now again, that is not my scale factor though. That just lets me know specifically that they're similar to each other. So let's make sure we remember, okay, so how do I find the scale factor again? Well, if I'm looking at A to G, remember scale factor doesn't come from using the two sides within A. It comes from comparing one side in A with one side in G. So A, the 8 and the 4 go together. They're the longer two sides. So to find scale factor from A to G, well, since it's getting smaller from A to G, instead of doing 8 divided by 4, I would do 4 divided by 8, which is a half. Okay? And so that would be my scale factor from A to G, which makes sense. Again, the side lengths are both half as big from A to G. Okay? So from B to F, well, B to F, if I pick, again, if I use the 4 and the 8 as well, like I have in the other shape, from B to F, it's getting bigger, so I would do 8 divided by 4, which makes 2 for the scale factor there. Okay? So F is 2 times bigger than B. All right, and then lastly, C to J. So from C to J, we can use the 9 and the 3 here. From C to J, it's getting smaller, so I'd put the small one on top, 3 over 9, which reduces to 1/3 as my scale factor. All right, so my scale factors are found by dividing. Let's write a little note on here. Scale factor comes from the corresponding sides. Remember, corresponding means the sides that go together, the sides that are in the same place on the two separate shapes, versus adjacent sides are the two sides within the same shape. So we can use both scale factor and adjacent sides to determine they're similar. There are two different ways to determine they're similar, but if we want specifically the scale factor, we have to use those corresponding sides and divide those. Okay? I do want you to notice something. If you look at the scale factor of a half, if you look at from this shape to this shape, notice the numbers are getting half as big this way. If I'm going that way, I'm multiplying times a half, right? Half of 2 is 1, half of 8 is 4. So the scale factor is how these two compare to each other. Same with this. As I'm going from this one to this one, notice both numbers are doubling, right? Both of these times 2 makes the two numbers over there, which was my scale factor. Okay, and this one as well. As I go from these numbers to these numbers, it's 1/3 as big. 1/3 of 3 is 1, 1/3 of 9 is 3. Okay, so comparing your two shapes, that's your scale factor. But just writing the ratio of the adjacent sides within a shape lets you know that they're similar to each other.